Hey guys, this is Gigi. I'm gonna attempt to explain question 1 in written assignment 10, and hopefully I'm not coughing all over the video here. So let's first graph the function. And so we know that a polynomial will be just a nice looking smooth curves. And the x-intercepts are when the y equal to 0, which means x is equal to 0, x is equal to -1, and x is equal to 2. Okay, so those are the x-intercept. And then the equation resembles x times x times x is x to the third with positive leading coefficient. So it's look like this. Okay, so it would be like so, up and down and cross. Okay, so that's the sketch of the function. And what we wanted to know in part B is the integral from -1 to 2 of f of x dx. So the integral from -1 to 2 of f of x dx. So the first thing first, let's multiply out 6x times x plus 1, x minus 2. That would be 6x multiplied by x squared minus x minus 2, which will give us 6x to the third minus 6x squared minus 12x. So the integral we are looking for is the integral of, and notice when you're listening to me and when you're watching the video, notice the notation. So we'll have then the integral from -1 to 2 of 6x to the third minus 6x squared minus 12x with respect to x. Okay, so the integral would have to have the dx written right there for it to make sense. Okay, so I see that in some of your work, you do not have that. But that is what describing the, remember how the integral comes about. The rectangles, right? The dx right there is describing the base of that rectangle, and then the f of x part is the height of that rectangle. So it is important to include that dx right there into your integral. And that will tell us which variable we are taking the antiderivative with respect to. Just like how when you are taking the derivative, you want to say dy dx, right? The derivative of y with respect to x. So that makes a big difference. It must be there, that dx or dy or whatever the variable is that you're dealing with. That must be there for it to make sense. Okay, so now with definite integral, we will first take the antiderivative. So this right here, this integral, is equal to the antiderivative, evaluating that from -1 to 2. So that's the notation, okay? The antiderivative evaluating from -1 to 2. So you draw a line like that, just to say we are having the upper limit of 2 and the lower limit of -1. Okay, so where this is the upper and this is the lower limit. Now we're going to take the antiderivative, so that would be 6x to the fourth divided by 4. 6 over 4 is 3 over 2. X to the fourth minus, we have x to the third, and the constant 6 divided by 3 is 2, minus x squared, and we have to divide out the 2, so that would be 6x squared. And we don't need to write the c like how indefinite integral is, because the c will essentially cancel out when you are evaluating at upper minus lower, right? So those c's are going to cancel out. So this will equal to, and we'll write that will equal to upper, which would be 3 over 2 multiplied by 2 squared minus 2 times 2 to the third minus 6 times 2 squared. Okay, that is the upper, minus the lower would be 3 over 2 -1 to the fourth power minus 2 times negative 1 to the third minus 6 times negative 1 squared. Okay, and that will equal to, I'll move this down, give it some room. That will equal to, when you do the calculations, this right here is 4, not 2. So then you will have on the x to the fourth, that would be 16. 16 divided by 2 is 8. 8 times 3 is 24 minus 8 times 2 is 16 minus 2 squared is 4 times 6 is 24. Okay, so all that will give us a negative 16 here in the front. Okay, negative 16 minus 3 over 2 times 1 minus 2 times negative 1 minus 6 times positive 1. So that would be 1.5 minus 2, or plus 2 actually. Minus minus is a plus. Minus 6, and that will give us a negative 2.5. So that would be minus a negative 2.5. So that would be minus minus is a plus, and the answer is negative 13.5. So that is the integral, okay? So we will say the integral from negative 1 to 2 of f of x dx is negative 13.5. Okay, now what's the difference between the area formed by the curve and the definite integral? Well, couldn't you just say the area is positive 13.5? The answer is no. No, that is not the case. Because some of the area here, looking from negative 1 to 2, this part is above the x-axis and this part is below the x-axis, right? When you combine those, the net area, which is the difference, is negative 13.5. So just because the area is positive doesn't mean you can just say, oh, that's just going to be a positive 13.5, because that's the net area, meaning the difference between those two values. But what we wanted to do is to add those two positive values together. Okay, so how do we deal with this? We would say that we would say that we're going to break this area into two parts. Okay, first we would have the first part would be the positive part already, so we will just count it as normal. So that would be negative from negative 1 to 0 of f of x dx. However, the second part going from 0 to 2, that is negative. So when that is negative, you have a couple ways of dealing with that. You can just go from 0, right? So option 1 is to go ahead and go from 0 to 2 as normal, knowing that that is going to be negative. So what we will have to do then is to go ahead and take the absolute value of it. Take the absolute value of it after you find that negative value. Or you can just go ahead and switch the order. Okay, so option 2 is to go from 2 to 0. When we switch the upper and the lower limit, property of integral said the answer is going to be the opposite. So the opposite of a negative number is a positive number. So I am going with option 2. Okay? So this would be plus the integral. Instead of 0 to 2, I'm going to go from 2 to 0 of f of x dx. And that account for the two area values being both positives. Okay, so the area will equal to, we know the antiderivative was 3 over 2x to the 4th minus 2x to the 3rd minus 6x squared. And the first integral, we are evaluating that from -1 to 0, plus the second integral is 3 over 2x to the 4th minus 2x to the 3rd minus 6x squared. We are now evaluating that from 2 to 0. Okay, so the area, when we plug in, we would say upper minus lower. So upper, plug in 0, I will have 0 minus, when we plug in -1, we have seen already before that this is going to be a -2.5, plus, when we plug in 0 here, we know already that's going to be 0, minus, when we plug in 2, we'll get a -16. So we can see that both of these are going to be positive. 2.5 plus 16 is going to be 18.5. So that is the area. Okay, that is the area formed by the curve and the x-axis. Okay, now if you really think about what this means, let's go back to our picture, right? The picture said this. I have this part here, and then I have this part here. The area formed right here is 2.5, and the area formed here is 16, right? So if you look at that, the integral from -1 to 2, the integral from -1 to 2 of f of x dx is the net area, where the positive part is 2.5 and the negative part is -16. So the net area is -13.5. That's the integral. Whereas the area formed is going to be 2.5 plus 16, and that is 18.5. So that is the difference between the area, which is question C, versus the integral in question B. Okay, so note the difference between the two. One is the net area, one is the total area. Net area is considering the sign area. So it's not really is like area, it's the sign area, right? And that's the difference between the two. So I noticed that some of you said there's no difference. Well, yes, there is. That's the difference. So note that learning process right there.